Hey everyone, thanks for checking out SPACEtomo. Today we are going to have a look at a full SPACEtomo run on a Lamella sample. So first we're going to start out by looking at the different settings in the SPACEtomo script. Number one is the automation level, and here you can choose between a few different ones. I usually go with number 4. Then what is important is the grid list, and that is just the slot in the autoloader. Next up is the Lamella setting that you just set to true if you are looking at the Lamella sample, or to false if you're not. And this will just trigger the object detection algorithm that can detect Lamella automatically. And the other important settings are the imaging states, and they are the imaging states that you have set up within serially. You can either give it a number of the imaging state or a name, and you need one for the whole grid map, which I call WG. You need one intermediate mag that shows roughly one square, which I call intermediate mag or IM. And then you need one low-dose state, at least one low-dose state, and that is usually a record low-dose state. But you can also give it a list of low-dose states if you want to include a specific view or focus state, for example. For this run, we want to check the output at every step, and we also don't want to do the automated target selection. So we set the whole grid wait for inspection to true, the manual selection to true, and the medium magnification wait for inspection to true. And with that all set to true, all the automated target selection settings don't play a role here. And with that, you're good to go. You just press run and SPACEtomo will take it from here. So first of all, it will ask you for a session directory. And this session directory will include subfolders for every grid that you currently have in the autoloader. So you can run it on several grids and it will automatically create a new folder for each grid. And within these subfolders, it will contain its own navigator, its own log files, and its own maps. The first thing SPACEtomo takes care of is loading the cartridge that you selected. Once that is done, it will have a look at the navigator, and if there's no whole grid map available yet, it will collect it. The whole grid map will then be rescaled to the pixel size that the Lamella detection model was trained on and saved as an image file. In the log, you can then see how the detection model goes over the whole map and detects, in this case, 10 Lamella. Immediately afterwards, the SPACEtomo region selection GUI will open up and load the whole grid map, and of course also show you all the detected Lamella. On the map itself, but also on the left side, you will have a list of all the different Lamella with their detected classes and their confidence. If you click on the name, it will zoom in and center on the given Lamella, and you can inspect it. You can also use the up and down arrow keys to move through the list. You can adjust the bounding box, move it or resize it, or you can remove Lamella completely if you think it's a false positive. Lamella 10 here is a good example of a false positive that sometimes happens. On the top there's a little button that zooms out the map again, and next to it there's also a button to take a screenshot of the plot only. Once you're happy with the result, you can simply click Confirm Inspection, and that will automatically save the Lamella coordinates to file. And then the serial.em script will pick that file up and place polygons at all stage positions that Lamella were detected and confirmed by the user. The next step for the SPACEtomo run is then to switch to the intermediate mag, in my case that is 580, move to the first Lamella, do a rough eccentricity, and then find the same Lamella again within this mag. And then the same is done for all the other Lamella. Next up is one more mag jump to the view magnification of your low-dose state, which in my case is 4800. And again, it will first try to take a view image and use the align between mags routine to compare that to the intermediate mag image. In some cases it might fail, and as a fallback it will just use the stage coordinate it determined at the intermediate magnification. So it's still helpful to have the magnifications aligned, but with all these align between mags routines it should be fairly robust even if your mags are not perfectly aligned. Once centered on the Lamella, it can go ahead and collect the view magnification montage or medium magnification montage that will then be used to place the SPACEtomo targets. After the first map is collected, the target selection GUI will already open, and you can start placing targets immediately, while in the background SPACEtomo will keep collecting more medium magnification maps of all the other regions. Regarding the target selection GUI, if you haven't, I would recommend watching my previous video on the target selection GUI in particular. It was recorded using version 1.1 and there's quite a few new features in 1.3, but the general workflow is very much the same. Once you load your map, you can zoom in, drag around, and look for potential targets for data acquisition. This actually might be a good example to show another new feature. We have a lot of ice contamination, and in case you want to go ahead and maybe manually try to remove it by irradiating the lamella, you can mark the map for reacquisition. There's a few options here, for example the padding, or you can also recenter the map using these sliders here. And once you're happy with your positioning, you can simply click Q, reacquisition, and it will remind you that it will only be reacquired once you restart the SPACEtomo run. So for now, let's move on to the next lamella and maybe set up a few targets here. And targets you can still simply add by holding down Shift and left clicking. Geopoints are added by middle clicking. And once you're happy with your selection, you simply click Confirm Inspection and the targets will be locked down. And once all the maps have been collected, the SPACEtomo script in the background will actually go ahead and prepare the serial EM navigator with all these new targets. Let me use this map to show you another new feature in version 1.3. Up here you can see there's some new buttons. This one is the polygon mode. And if you're in polygon mode, you can simply click anywhere on the map and start drawing a polygon. Once you click on the first point again, it will be a closed polygon. Once you have your polygon, you can click on this button to add a dense pattern of targets. Not targets, in this case it's actually target suggestions, and you can add all of these suggestions by clicking the Add Target Suggestions button. Of course, you can then still go ahead and place your tracking target on whichever target you prefer. And once you're happy, you can click Confirm Inspection. But before we do that, we should add a few geopoints. And in this case, you can actually see that it's quite advantageous to have a higher mag and smaller beam diameter focus area, so you can place and squeeze your geopoints in between your actual targets without causing too much exposure damage. All right, so this last one actually looks quite contaminated again. So maybe we should just go ahead and set this one up for a reacquisition. Let's have a look here. Maybe we'll adjust the padding a little bit and recenter it with the sliders. And that's about good enough. All right, Q reacquisition. And since this was the last one, let's just check serial EM quickly. Yeah, the SPACEtomo run is already completed and in the navigator all the targets are set up, so we can close the GUI and we end up with the full navigator. All the SPACEtomo target areas are already here. And if we just load one of the Lamella maps, we can actually see what the navigator looks like. We have the maps and the geopoints all here and visible inside serial EM. But since we do want to reacquire some of the maps again, we will have to rerun the SPACEtomo script before we start the SPACEtomo acquisition. And since SPACEtomo ended in the grid directory, we have to actually be a bit careful here and go a few folders up to go back to the session directory where SPACEtomo can find all the different subfolders for the different grids. As serial EM does not have access to the information which grid is on the stage, it will usually ask you to confirm. Then it will already find the whole grid montage, quickly load it, load intermediate mag image just to get all the pixel sizes. And then it will find which maps have been marked for reacquisition and only acquire these specific maps. Now we of course didn't go ahead and try to clear some of the accumulation, but you can see that the map is much tighter since we reduced the padding. And once again, as soon as a map is finished, the target selection GUI will open and already show you all the previous maps that have been collected and marked as inspected. And also the new maps will pop up as soon as they are collected. All right, I'm not going to place any targets here. I'm just going to confirm for the inspection. And in this case, it asked me if I want to close the GUI because all of the maps have been inspected. But as we can see in serial EM, it is still collecting. So in this case, I will press wait. All right, let's have a quick look at the last map here. And let's just go through the polygon workflow once again. I'm gonna place a polygon covering the whole lamella. and then I'll press the dense pattern buttons, and this will place the patterns of target suggestions all over the lamella. I can click add target suggestions, which will add all of them. And then as we can see here, half of them actually have this red asterisk, and that means that the image shift required to reach the target from the tracking target is beyond the image shift limit in serial EM currently set. And to remedy that, we can make a new tracking target. And here it is important to make a tracking target of a new area, which will split the targets into 2 independent SPACE-tomo areas. Then on the bottom here, let's center this tracking area as well, in this case of the current area, because we don't want to change it. And then we can just click redistribute targets to sort every target by their closest respective tracking area. Alternatively, let's just quickly merge the target areas again. We can also use the split target areas button, which will use k-means clustering, which will immediately divide the targets into 2 clusters with their respective tracking areas. All right, with that, we are ready to confirm inspection. Oh, we didn't place any geopoints, so let's go ahead and quickly do that. We're going to squeeze a few in. Here it is important to remember that it will only use the geopoints that are within the image shift limit of a tracking target. So we should place a number of geopoints around both of these SPACE-tomo acquisition areas, just to be sure that they have enough geopoints. All right, confirm inspection. And we can now close the GUI, and we can see in serial EM how SPACE-tomo will set up these virtual maps and add it to the navigator and mark the tracking targets for acquisition. And with that, the SPACE-tomo run is completed, and we are ready to simply run the normal SPACE-tomo script on all the targets that have been marked for acquisition. Okay, thanks for making it all the way through. As always, if you have any questions, please feel free to reach out on the GitHub page or just send an email to spacetomo.help@gmail.com. I'm always happy to help out if you run into any issues, and of course, always happy to hear of any bugs that I can fix. Thanks again, and good luck collecting data.